It's World Tuberculosis Day, and, we're always looking for innovative solutions to global health challenges, right?
Absolutely.
Well, get this. One of the most surprising weapons in the fight against TB isn't a new drug or vaccine. It's actually a technology we usually associate with, like, skyscrapers and massive infrastructure projects.
Oh, wow.
Building information modeling, or BIM.
Interesting.
Yeah, and today we're going deep on BIM, seeing how it's being used to design, build, and even run TB treatment facilities in ways that are, well, frankly, more effective and ultimately could save more lives.
That sounds pretty fascinating, actually. What exactly is BIM? I mean, I've heard the term, but I don't really know much about it.
So think of it like this. It's like a super detailed digital 3D model of a building, but it's not just a visual thing. It contains tons of information about every single component, every system, every material, everything.
Oh, I see. So it's like a digital blueprint on steroids.
Yeah, exactly. And the cool thing is that this information can be used for so many different things throughout the entire life cycle of the building, from the initial design phases all the way through to construction, operation, and even demolition.
Okay. I'm starting to see how this could be useful for something like a TB treatment facility.
Yeah, and one of the key areas where BIM is making a huge difference is in ventilation systems. You might think, okay, ventilation, that's pretty basic. But for TB, it's absolutely critical because TB is an airborne disease, right?
Right.
So we're talking about using BIM to simulate airflow within a building. And by doing that, we can pinpoint the areas where the risk of TB transmission is the highest.
Ah, that's smart. So like identifying potential hotspots before they even become a problem.
Exactly. And it goes way beyond just opening a window or two.
So how does it actually work? How do you simulate airflow with BIM?
Well, they use something called computational fluid dynamics simulations. Sounds complicated, but it basically allows them to visualize how air moves through the entire building, every nook and cranny, and then they can make super precise adjustments to the design, like strategically placing air inlets and outlets, creating pressure differentials that effectively isolate contaminated air and direct it away from patients and staff.
It's almost like creating an invisible shield against TB transmission just by manipulating the airflow.
It's pretty incredible.
Yeah.
And this level of precision isn't just theoretical. It directly helps meet those World Health Organization guidelines for TB infection control.
Right.
So we're not just designing a building, we're designing a space where the very air we breathe is actively working to prevent the spread of TB. It's pretty amazing, right?
Yeah, that's really impressive. I mean, it's like using technology to create a safer environment for everyone.
Now let's talk about something that sounds like it's straight out of science fiction. Digital twins.
Digital twins, what are those?
So we've got this incredible building designed with BIM, right?
Yeah.
But how do we ensure that it's functioning optimally, especially in critical areas like negative pressure rooms, which are essential for containing airborne infections? That's where digital twins come in. It's like having a virtual replica of the hospital that's constantly receiving real-time data from the physical building.
A virtual replica. Okay, I'm intrigued. So you're saying there are sensors in the building sending information to this digital twin?
Yep. And these sensors monitor everything like air quality, humidity, temperature, even the performance of equipment in those negative pressure rooms.
So it's like the building itself is telling us how it's feeling and whether everything is working as it should.
Precisely. And this constant stream of data isn't just for observation. It's about proactive management. We can identify potential issues, like a drop in negative pressure or a malfunctioning air filter, before they become major problems.
I get it. So it's all about preventing those crucial infection control measures from failing, which obviously have huge implications for patient and staff safety.
Exactly. That level of real-time monitoring and responsiveness is really a game changer.
It is. It sounds like BIM and digital twins could be a powerful combination in the fight against TB.
Absolutely. But let's shift gears a bit. One of the biggest challenges with TB control is, well, the speed. We need to build treatment centers quickly, efficiently, and often in areas that are hit hardest by the disease. It's not always easy to construct a traditional hospital in a remote region with limited resources, right?
Right. I can see how that would be a major obstacle.
So how does BIM help us overcome those hurdles?
Well, this is where prefabricated modular construction comes in. BIM lets us design these modules off-site, complete with all the necessary features for TB care.
Like, what kind of features are we talking about?
Well, think optimized layouts for patient isolation, integrated ventilation systems, all those things we talked about earlier.
Ah, okay. So it's like having these high-tech, self-contained units that can be transported and assembled on-site, like giant building blocks.
Yeah, that's a good way to put it. And because they're prefabricated, it significantly reduces the on-site construction time, which is crucial in these situations.
Right, but how do we make sure these modules are adaptable? I mean, they need to work in different environments, integrate with existing infrastructure and all that.
That's the beauty of BIM. It allows us to factor in all those considerations from the very beginning of the design process. We can model the modules to fit specific site conditions, account for local climate and terrain, even incorporate existing infrastructure elements into the design.
So it's not just about speed and efficiency. It's about creating sustainable solutions that can truly meet the needs of diverse communities.
Exactly.
Now, I have to admit, when I saw 4D and 5D BIM mentioned in our research, I thought we were venturing into some kind of alternate dimension. Can you break down what these extra Ds bring to the table?
They might sound futuristic, but 4D and 5D BIM are all about bringing a practical, data-driven approach to construction.
Okay.
So 4D BIM incorporates the element of time. Imagine being able to visualize not just the final building, but the entire construction process, broken down into phases and sequences.
So it's like having a time-lapse video of the construction project before it even begins.
Exactly, and this allows for incredibly precise scheduling, which is crucial for these complex projects. We can ensure that materials arrive on time, that different trades work together seamlessly, and that any potential delays are identified and addressed proactively.
Makes sense. And 5D BIM adds the element of cost, right? Which is obviously critical, especially in resource-constrained settings.
Precisely. With 5D BIM, we can generate highly accurate cost estimates. We can break down the project into its component parts, track expenses in real time.
So it's all about transparency and making sure the projects stay on budget.
Exactly, and that resources are used effectively.
It's amazing how BIM can bring together so many different aspects of a project, from design and construction to time management and cost control. And our research suggests that the future of BIM in TB control may involve an even more powerful ally, artificial intelligence.
AI, Now that's really getting futuristic.
Right. So how can AI and BIM work together to improve our efforts against TB?
Well, imagine combining the detailed spatial information of a BIM model with the analytical power of AI. We can use AI to analyze tons of data, things like TB case distribution, population density, even environmental factors that contribute to the spread of the disease.
And then all that information can be fed back into the BIM model to inform the design and placement of new treatment facilities, right?
Exactly. So we're ensuring that these facilities are located not just where TB cases are most prevalent, but also where they'll be most accessible to patients and have the greatest impact. We can even use this data to predict future trends and proactively plan for the evolving needs of communities affected by TB.
It's like using data to map out the most strategic battle plan against TB, making sure resources are used in the most effective way possible.
That's a great analogy.
I also read that GIS, Geographic Information Systems, can play a role in this whole process too.
Oh, absolutely. GIS adds a critical layer of geographical context. We can integrate data on transportation networks, existing healthcare infrastructure, even socioeconomic factors into the BIM model.
So it's like creating this incredibly comprehensive picture of the region, which allows for much more informed decision-making.
Exactly. It's about taking a holistic approach, considering all the factors that contribute to the spread of TB, and then using that information to develop the most effective solutions.
It's really impressive to see how all these different technologies can come together to make a real difference in the fight against a global health challenge like TB.
It is. And what's exciting is that this is just the tip of the iceberg. The potential for BIM, especially when combined with technologies like AI and GIS, to revolutionize global health is huge.
So what we've learned today is that BIM isn't just a tool for architects and engineers. It's a powerful weapon in the fight against TB and potentially other diseases too.
Absolutely. It's transforming the way we design, build, and operate healthcare facilities, ensuring they are optimized for infection control, patient care, and long-term effectiveness.
It really makes you realize that the future of healthcare is not just about new medicines or treatments, but about using technology and data to create a healthier and more resilient world.
I completely agree. It's about using these tools to address the root causes of disease and to build a future where everyone has access to the care they need.
It's definitely something worth thinking about. And who knows what other amazing applications we'll find for these technologies in the years to come.
The possibilities are endless.
They really are. Thanks for joining me on this deep dive into the world of BIM and its role in TB control. Until next time.
It was my pleasure.
Bye.
Bye.